Okay, good morning class. So today we're looking at analytical geometry. I think we're on our third lesson today. You guys had homework, it was exercise 4.3, correct? Right? Right. So let's look at number 1. Any sum in particular you want me to do in number 1? No? Okay, so I'll again choose a few sums here because I know many people who do the section, they have problems here, but you guys are a bit special. No? You guys know what's going on? In the exercises. No? Not in the exam. The class test. But anyway, let's go. Number 1. This is exercise 4.3. And it's on page 93. Alright, so basically what we have here, we're going to go with 1a. So you got y is equal to 2x minus 4. So the question says, calculate the inclination of the following straight lines, giving your answer correct to one decimal place when necessary. So what's the gradient of this line? 2. So we know that tan of theta equals 2. So arctan of 2, we got arctan of 2 gives us 63,43. So 63, let's look at B, not BC. Doing every second sum. So we got y is equal to negative 3x minus 1. So as you can see here, we have a gradient of negative 3. So we say tan of theta is equal to negative 3. Arctan of negative 3 gives us negative 71,56. So it's negative 71,56. So we add 180. Because the angle is obtuse. Plus 180 gives us 108,4. Or 4 degrees. Okay. Let's look at the next one. E. So if we look at E, we got y plus x equal to 7. So is that equation in standard form? No. So you take an x over, so y is equal to minus x plus 7. So the gradient of this line is negative 1. So we say tan of theta equals negative 1. Arctan of negative 1 is negative 45 degrees. We add 180 to it, get an angle of 135. Let's look at G. G of x, you got 4, y is equal to 3x minus 8. Is that in standard form? No. So you divide by 4 both sides, so it's 3 over 4. X minus 2. So what's your gradient of that line? 4 over 3. So I say tan of theta equals 33 over 4. So theta is equal to shift tan of 3 over 4 gives us 36, 9. Okay, that's G. Look at I. We've got 3y plus x equals 4. Get in standard form, so 3y is equal to minus x plus 4. Divided by 3, so it's negative a third x plus 4 over 3. So what's the gradient of this line? Negative a third. Tan of theta is equal to negative a third. So arctan of negative a third. It's going to be negative 18, 4. Be then add 180 to it, because the angle is obtuse. Gives you 161, 6. Okay. Number 2. So exercise 4.3 on page 93. Calculate the inclination of the straight line passing through the following pair of points. Give your answer correct to 2 decimal places. So let's look at A. So we know that tan of theta equals the gradient. The gradient is y2 minus y1 over x2 minus x1. So it's going to give you 12 minus 4 over 1 minus minus 3. So theta is equal to arctan of, that is going to be 8 over 4, which is 2. So arctan of 2 gives you 63,4. Let's look at C. The tan of theta is again equal to the gradient. So it's going to be 9 minus minus 3 over 4 minus 7. So theta is equal to arctan of 12 over negative 3 is negative 4. Is that correct? So you say arctan of negative 4 gives you negative 75, 96 plus 180 gives us 104, 0, 104. Is that correct? Right. Let's look at E. The tan of theta equals the gradient, which is negative 6 minus minus 2 over 1 minus minus 1. The theta is equal to arctan of negative 4 over 6. It's negative 2 over 3. So theta is equal to arctan of negative 2 over 3. So negative 33,69. We add 180 to it. And 46,3 degrees. Is that correct? 46,3. And then G, tan of theta equals the gradient. So it would be 1 minus minus 4 over 5 minus 5 minus minus 3. So theta is equal to arctan of 5 over negative 2. Arctan 5 over negative 2 is negative 68,1 over negative 68.2 degrees. We add 180 to it, so the angle is obtuse. Gives you 111.8. Okay. Any confusion there? You will understand. So now we're going to look at more complex examples, okay? And this is on page 93. Right. More complex examples is the example on page 93. We tell straight line y is equal to 2x. and y is equal to negative 3x plus 6 intersect at A. As you can see, there's a point of intersection there. Beta and theta inclinations of the two straight lines respectively. Okay, so y is equal to 2x as the angle of beta, and y is equal to negative 3x plus 6 as the angle of theta as the inclination angle. Refer to the given diagram and calculate the value of the following, correct to one decimal place. So if you look at what we have here, we have this angle beta that we need to work out. Not so? So what do we need in order to calculate beta? We need the gradient, not so? So what's the gradient of that line? 2. So we say tan of theta equals 2. So work out the angle for me quickly. So theta is equal to 63,43 degrees. You all agree with that? So here goes 63,43. Beta wants you to work out theta. So how are we going to calculate theta? We need the gradient again. Not so? Cheryl? Taking note? Right? We need the gradient again. What is the gradient of that line? Negative 3. Where do we get that from? From this. Remember, that's in the form of y is equal to mx plus c reading. Not so? So your gradient is negative 3. So you're saying tan of theta equals negative 3. It's actually, I made a mistake here. That's supposed to have been beta. Okay. The tan of theta is equal to negative 3. Work out that angle quickly. Your arctan of negative 3, negative 71,56. Then what we do, we add 180 degrees to it. Gives you 108,43 degrees. That is this angle here. Remember, this negative angle of negative 71,56 is actually that angle B. Okay? And to get that angle is since those two angles are supplementary, and just add 180 to the negative angle. You all okay with that? Then the question says calculate A1. I want you to calculate A1. So how do you think we're going to calculate A1? Huh? Exterior angle is equal to the sum of the two interior opposites. Can you see that? Your exterior angle is equal to the sum of the two interior opposites. So what we say here is going to be 108,43 is equal to 63.43 plus angle A1. You guys understand? This angle A1 is going to give you an angle of 108,43 minus 63,43. Give an angle of 45. Okay? Any confusion? Any questions? Right, we'll do another one. The second page. I don't need this anymore. Here's the first sum in exercise 4.4. page, sorry, 94. So I'm going to pause the video at this point. I'm going to give you a couple of minutes to solve the first question, okay? Alright, so let's look at this one here quickly. We are told that in the diagram the points A, which is 1 and 0, B, which is 4 and 0, and C, typing it there, 3 and 4 are given. Angle A, 1, and angle B, 1, inclination of angles AC and CB respectively, which means to say, in that order. The question says, calculate the size of the following correct to one decimal place. Alright, so this is number 1. Okay. So to calculate the angle A1, what do I need? I need the gradient of AC, not so. So tan of angle A1 is equal to the gradient of AC. So how do you calculate gradient? Y2 minus Y1 over X2 minus X1. Give me a gradient of 2, not so. So arctan of 2 gives us an angle of 63,4 degrees. Okay, you all agree with that? Then they want you to calculate B1. So how do I calculate angle B1? I need the gradient of CB. You all agree with that? How do I work out the gradient? Is y2 minus y1, so it's 4 minus 0 over 3 minus 4. So that gives me a gradient of negative 1, not so? Is that negative 1? Did you guys get this far yet? What did you get for the gradient here? Negative 4, sorry. Well, that's why it's a point, okay. Sorry man, my mistake. I said negative 1 is negative 4. So arctan of negative 4 is what? Arctan of negative 4, negative 75,96 plus 180 gives you 104,0, 104. 104 degrees. You all agree with that? Then the question says, you must calculate angle C. So I'm going to calculate angle C. Exterior angle is equal to sum of two interior opposites. Not so? So what do I say? 104 degrees equals 63.4 plus angle C. So angle C is equal to 104 minus 63.4. So 104 minus 63.4 gives us 40, okay, is there anybody that's confused? You all, who doesn't understand? You all understand? Yes?
Not V1, but the angle
C? VA. So you are asking with regards to this angle here. So you say that angle is 104. You're asking that. You see, if I extend this line CB down here, then that negative angle here, this negative angle that we got here, is actually that angle B. Can you see that? Now to get the one, the obtuse angle, add 180 to the negative angle. Okay. Remember that the inclination, the angle of inclination, is always made with a positive, from the positive x-axis onto the line. So if your line is here, then that would be your angle of inclination. If a line is there, that will be still your angle of inclination. So you're always starting with a positive x-axis. Always in that direction, from that point. Okay? Any other confusion? Alright. Okay, so for homework is number 2. Number 3. Let's do number 4 quickly. Okay. We're told that lines y is equal to negative x plus 1, which is this line here, and y is equal to x minus 1, which is this line here. Both intersect on the x-axis at the point is. The angle beta and alpha and inclinations of y is equal to negative x plus 1 and y is equal to x plus 1 in that order. First question says, calculate beta. Okay. You guys know what to do here? Yes? Alright, I'll pause the video again for a couple of minutes. Then I'll give you a chance to answer these questions, okay? Alright, so the first question says calculate the size of the following predicted one decimal places, beta. So angle beta, which gradient do we need? Be the gradient of tan of beta is equal to the gradient of ts, which is negative 1. Not so? So we'll say angle beta is equal to arctan of negative 1, which is negative 45 degrees. Not so? When I add 180, I get 135 degrees. You all agree with that? Then the second part of the question says, calculate alpha. So how do we calculate alpha? I need the gradient of QS. Not so? So the gradient, so tan of theta, in this case actually alpha, tan of alpha is equal to 1. So alpha is equal to the arctan of 1, which is 45 degrees. Not so? Then they want you to calculate the size of TSQ, which is this angle here. How are you going to do that? You're going to be your beta minus your alpha angle. Not so? We'll give you this angle here. So remember, that was your beta, and that is your alpha. So you subtract the 2. So TSQ is equal to beta, which is 135 degrees, minus your 45 degrees, which is? Okay. You all understand? Any confusion there? Alright, so that is number 4. Number 5 is similar to what we just dealt with in the previous sum here. In the same way. Okay? The next heading, equations of straight lines. Equations of straight lines. First example after this is on page 97. Lead up to the example, get to the example on page 97. It leads up to this way. So at this point we are told the equation of straight lines. The standard form of the equation of the straight line is y is equal to mx plus c, where m is your gradient of the straight line and c is your y-intercept. Write that note down. Now consider the straight line where we are given the coordinates of a specific point, say A, which is x1, y1, and B, okay, x1, y1. Let us also consider another arbitrary point B, which is x and y on the straight line, whose coordinates are not known. Okay? Then we have to tell therefore m, which is x minus x1 equals y minus y1, therefore m. Okay, but we've dealt with gradients many times before, okay? Thus y minus y1 equals to m into x minus x1 is another form of the equation of a straight line that can be used if we know the gradient and the coordinates of one point. Okay, so people, this is another formula we can use. Instead of y is equal to mx plus c, we can use this formula. Okay? I use the other one most of the time. If you decide or you prefer using this formula here, you should get the same answer that the others get. Okay? Provided you don't make a mistake. The general form of the straight line equation, y is equal to mx plus c, and the gradient is mc is your y-intercept. When using this, we know that the gradient and the y-intercept. Then the coordinates of a point on the line, we've got the gradient, y minus y1 equals m into x minus x1. The gradient, we use this when the gradient and the coordinate of at least one point on the graph. So again, if you prefer using the second form, no problem. Okay. I just prefer using the first one. Note in general, in order to determine the equation of the straight line, we need to know the gradient m of the line and the coordinate x1, y1 of the point on the same straight line. Okay. So that's that. We may use either the formula that or that. However, the second formula is easier to use if you are given the gradient and the coordinates of one point on the line. Most of the time, you need to calculate the gradient. Okay? Whichever form the equation of the straight line you choose to use, you will always have to determine the gradient. The following table will give you the four methods of calculating the gradient of a straight line depending on the information given in the question. Okay? If you're that kind of girl who likes writing, you can go write that down, and this is on page 97. We are given the coordinates of 2 points in the, on the straight line. F is equal to y2 minus y1 over x2 minus x1. Two parallel straight lines. People, if lines are parallel, what we know? Gradients are equal. I think we made this note already, no? Yes. Two perpendicular straight lines where the gradient, we know one of the two gradients, so m1 times m2 is equal to -1. The inclination tan of theta of a straight line is tan of theta is equal to your gradient. You know, that's basically what we have been dealing with thus far. Okay. We will be looking at example 1, and this is on page 96. The question says determine the equation of the straight line which passes through A, which is 3 and 4, and has a gradient of 2. So where do I start? I started by writing the formula. Y is equal to mx plus. What is the gradient? 2. So y is equal to 2x plus c. So how do we calculate that c value? You substitute the point that the graph is going through, which is A. So do that quickly. Okay, So what do we have? Y is equal to 2x plus c. We substitute a, which is 3 and 4. That's a x and a y. Not so? So 4 is equal to 2 times 3 plus c. What's 2 times 3? 6. So 4 minus 6 is negative 2. So y is equal to 2x minus 2.
Mr. Bodine?
Yes, miss?
Mrs. Kleinans is coming now to your classroom
Oh.
to relieve you. Then you need to report to the bottom conference room, please, sir.
No problem, miss.
Thank you.
Okay. Okay, to determine the equation of the straight line passing through A and B. I'm sure you guys know how to do this. Okay. Determine the equation of the straight line passing through points A and inclination of 45. What's the difference here? This is a theta angle is. Not so? So we say tan of theta is equal to the gradient. So the gradient is equal to tan of 45, which is 1. You all agree with that? So y is equal to 1x plus c. At this point we can substitute a, which is 2 and negative 3. You all agree with that? So that's a x and a y. So negative 3 is equal to 1 times 2 plus c. So c is minus 5. Therefore y is equal to x minus 5. You all okay with that? Okay. Is there something new there? Determine the equation of the line passing. Okay. If lines are parallel, what do we know? Gradients are equal. If you look at example 4, the equation is 4x plus 3, 4y plus 3 is equal to 8. So we must first get that in standard form. Then we can see the two gradients equal to each other and then take it from there. You all agree with that? Okay. In our next lesson, I'm going to do all of that calculations. I just have a meeting with somebody from the department here. So you guys are going to do for me for homework exercise 4.4. You come inside this. You do for me A and C. Number 2, A, C, E, G. Number 3, A and C. Number 4, A and C. Number 5, A and C. Okay, and that is for tomorrow. Alright? So you're going to do every alternate sum for me. Alright? People enjoy the rest of your day. Good morning, class.